Hello, this is Rob Reiner, Director of Product Marketing for Tachyum. In previous demonstrations, we've shown Linux booting on the Prodigy emulation system. Today, we'll demonstrate the system executing more complex applications. The system has already pre-booted Linux to save time. This system is based on Linux 6.1 with sysv init. The root file system contains Python and the full native GNU2 Chain with GCC 12.2 compiler. Both Python and GCC are complex applications. Having a full native toolchain on the system allows us to build many other packages from sources. Let's first run a Python script. This script takes an input number in digit format and writes it back as text in a written sequence. Let's feed it a few numbers and see how it works. We'll type echo a series of digits and pipe it to Python. As you see, Python is working as expected. Let's now switch to the GNU2 Chain, and instead of an interpreter, let's compile some C sources into native Prodigy binary. Let's use it on the Steam Locomotive Mini C project of Toyota Masashi, which is probably known by many users who accidentally type SL instead of LS. We've produced our Prodigy binary. Let's run it and observe our train leaving the station. Let's switch gears and discuss how we run regression testing on our FPGAs. We'll start by running the test float verification test suite, which ascertains IEEE compliance. For our regression tests, we package all the binaries we want to verify running as expected into a separate init ramfs image, which contains the Linux kernel, applications, their inputs, and reference output, which we expect to see every time we run it. The system is configured for auto login, followed by a testing script running at startup. The testing script compares actual output with reference and displays pass or fail. Our automated systems run many scripts every night and monitors the regression status. As an example, you can see the test float test suite we launched earlier is running and producing test results. Berkeley Test Float is a well-known compliance checker created and maintained by Professor John Hauser of UC Berkeley. We're using the most recent 3E version of the suite to perform our verification. This is work in progress. So far, we are fully clean on 48 of 58 available modules. The remaining few still flare up in some corner cases, but we expect to clean it up soon. As we said, it's a work in progress. What you're seeing now is the automated image running on 48 passing tests, exactly the same as our regression check would run it. Another interesting set is the spec 2006-2017 benchmarks. We'll start by running a few of those. These benchmarks consist of multiple complex applications selected by spec.org to be a representative workload, which are performed on modern computer systems. We selected a few that are capable of finishing reasonable times. While the FPGA emulator is a great verification vehicle, it's not as fast as an ASIC, close to 100 times slower, so we need to be mindful in our dataset selection. We see that it's running, producing output, and being compared with the references. It will take quite a while longer. We will let it run and wrap it here for today. We have all the applications needed for Prodigy tape-out qualification, and all of them are successfully running on our software-based emulator, and many of them are cleanly executing on our FPGA emulation system. Once the entire qualification set of applications is running cleanly on the FPGA emulator, Prodigy will be ready for tape-out later this year. Thanks for watching our presentation, and stay tuned for additional Prodigy milestones.